Section 1.4 covers pairs of angles. Some of these may be reviewed to you, and some of them may not. So if it is reviewed to you, once again, you can skip over the definitions when I explain them and go right into the examples. Many pairs of angles have special relationships. Some relationships are because of the measurements of the angles in the pair. Other relationships are because of the positions of the angle in the pair. The first vocab word is adjacent angles. Adjacent angles are two angles in the same plane with a common vertex and a common side, but no common interior points. So let me draw an example. You have an angle. Let's say this is angle 1. You have another angle. Let's call that angle angle 2. Notice that they share the same vertex and they share the same side. They're basically angles that are right next to each other. So angle 1 and angle 2 are adjacent angles. A linear pair of angles is a pair whose non-common sides are opposite rays. So, if I have an angle, let's say I have an angle 3 and angle 4. They're adjacent. They're right next to each other. So they're adjacent angles. Here's the easiest way to look at them. They're adjacent angles whose non-common sides, that'd be this side here and this side here, the sides that are not common, they are opposite rays. Basically, these are two adjacent angles that form a straight line. So if you have a straight line and two adjacent angles, therefore you have a linear pair. Linear, it makes a line. Example number 1. This you can just watch. You don't need to write any of this down. It is all on page 28, but I want you to just pay attention to me. Tell whether the angles are adjacent and a linear pair, or not adjacent at all. So let's look at angle 1 and angle 2. Angle 1 is right here, and angle 2 is right here. So it sometimes helps, if you're confused on what angles they are, to redraw just those angles. So what are these two angles right here? Well, they share a common vertex and a side. Therefore, they are adjacent angles. They do not make a line, so these are just adjacent. And I'm going to abbreviate adjacent. All right, the next one is angle 2 and angle 4. So angle 2 right here and angle 4 right here. So angle 2 looks like it's going to be right here and angle 4 right there. Well, they share a common side, but they do not share a vertex. Therefore, they are not adjacent. So not adjacent. And if they're not adjacent, they can't be a linear pair. And lastly, 1 and 3. So 1 and 3 are right here. Angle 1 and angle 3. Well, they do. So here's angle 3, here's angle 1. They do share a common side and vertex, and they make a straight line. Therefore, they are adjacent and a linear pair. These are probably review for you, but we'll go over them anyway. Complementary angles are two angles whose measures have a sum of 90 degrees. Supplementary angles are two angles whose measures have a sum of 180 degrees. So a lot of people think that they have to be next to each other. They don't. Usually, however, two angles that form a right angle are complementary. Two angles who make a straight line are supplementary. However, that is not always the case. Supplementary, complementary do not have to be next to each other or adjacent angles. Example number 2. Find the supplement of angle N. We can see that angle N has an expression of 2y plus 20 degrees. Supplements mean, well, they're two angles that would be supplementary, which means they add to 180. So if one angle is 2y plus 20, how do you find the other? Well, you subtract it from 180. So you would take 180 minus what the other angle is, which is 2y plus 20. Distribute the negative for the negative 1. So 180 minus 20 is 160. So the other angle would be 160 minus 2y degrees. All right, the next example is example 3. So a lot of you, when you do complementary and supplementary angles, it's really easy to do problems that say two angles are supplementary. One of them is 50. What's the other? Well, you take 180 minus 50 and get 130. That's it. Those are easy. I could give you a whole bunch of those, but what's the fun in that? So we're going to make it a little more difficult. So here we go, example 3. An angle measures 3 degrees less than twice the measure of its complement. Find the measure of its complement. Here's what I would do first. If you have an angle, obviously we have two angles, so you could say angle A and angle B. We know that we have two angles here. So we're talking about their measures, so don't forget the measure. This is why if you use your algebra skills, set them up. I don't care which angle you want, but let's let it be the first one. The first angle is x. The other angle is its complement. So, if they're complementary, one angle is x, the other angle would be 90 minus x. Because if one angle is, let's say, 30 degrees, how do you get the other? You subtract it from 90. Because complementary angles are two angles that have a sum of 90 degrees. What does this say? An angle measures 3 degrees less than twice its complement. So an angle, well, that's the measure of angle A. An angle measures, or an angle is, so it says 3 degrees less than twice the measure of its complement. So this is the complement. So twice the measure of its complement, and then 3 less than that, so minus 3. So if we plug these in, we're going to substitute the measure of angle A. So we have an angle. One of the angles is x. It measures twice the complement, and it's 3 degrees less than that. So let's look at what it says. An angle measures 3 degrees less than twice its complement. So now we solve this. X equals, distribute the 2. I'm going to add the 2x to the other side, so that gives us 3x. 180 minus 3 gives me 177. Divide by 3, these are all review skills from algebra last year. 177 divided by 3 gives me 59. That is the measure of x, not the measure of the complement. The complement is 90 minus that. So one angle is 59 degrees. What's its complement? Well, 90 minus 59 gives us 31 degrees. So the complement is 31 degrees. Example number 4. Now this picture is on page 30 if you want to follow along. It says that light passing through a fiber optic cable reflects off the walls in this way. So light reflects as it bounces off this fiber optic cable. We know that angle 1 and angle 2 are congruent. Angle 1 and angle 3 are complementary. Angle 2 and angle 4 are complementary. We know the measure of angle 1 is 38 degrees. Try to solve this yourself. Pause the video, figure out the measures of angle 2, 3, and 4. Hopefully, you realize that the measure of angle 2 and the measure of angle 1 are the same thing. So if the measure of angle 1 is 38, the measure of angle 2 is also 38 degrees. Because 1 and 3 are complementary, that means that these two angles here form a 90-degree angle. So 1 and 3 add up to 90, so 90 minus 38 would give us 52 degrees. And 2 and 4 are complementary, so once again, 90 minus 38 would give us 52 degrees. So our three angles would be 38 degrees, 52 degrees, and 52 degrees. The last vocab word are vertical angles. Vertical angles are two non-adjacent angles, they're not next to each other, formed by intersecting lines. A lot of people want to think vertical angles are across from each other. And while they are, not all angles across from each other are vertical angles. So I have two intersecting lines. And I'm going to name them 1, 2, 3, and 4. In this case, angles 2 and angle 4 are vertical, and angle 1 and angle 3 are vertical. What's the other thing you probably already know about vertical angles? They're congruent. So angle 2 and angle 4 are congruent, angle 1 and angle 3 are congruent. We have two angles that are, they are across from each other, but they're non-adjacent. Today's vocabulary are the 5 sets of angles you see there.